Hi everyone. So here we are again. So today we are going to solve for this 1, 2, 3. So we will start from here. Okay, 1. Okay, 1, 2. No, 1, 2, 3, 4. Okay, we are going to solve this. Okay, what I'm doing just to try to solve a bit of everything so that you can have some ideas. Okay, to solve problems related with this one. Okay, then let's go just. So I will start with this one. So this is an exercise like this one. They are asking to analyze the convergency of the series. So this is 1 times 2 plus x squared and 3, 4 plus x3, and this is 4, 5. Okay, plus on. So the first thing we have to understand here is how to find the UN. Okay, how to find UN here. See, this is the first term, n is equal to 1, 2, 3. So just by seeing, you can understand that here, and this is the power for x, it is increasing from 1 to infinite. 1, 2, 3, so and so on. This is x raised to n. Okay, so this is a power function. Power series. Okay, power series. Then we have upon. Then we have this 1, 3, 4. This number are changing. Then we have this 2, 4, 5. If we just look very well, 1 to 3, okay, there's a difference. The difference between 3 and 2 and 1, it is 2. And the difference between, here it is 5. Okay, and here it is 6. Yeah. And the difference between 3 and 5, it is also 2. So, as the difference between them are constant, so they can be considered as a arithmetic progression. And they can be written in this way. an is equal to a1 plus n minus 1 times the difference. So, what is a1? A1 is the first term. 1 plus n minus 1 time d. D is 2 because the difference between them is 2. Just solve for this one, you get 2n minus 1. Okay, means that here this, and this can be written in general term like this, 2n minus 1. Okay, now for the second, you have 2n, 4n, then 6n. Okay, so it is also arithmetic progression. If you just go there, you will find that 4 minus 2, it is 2. 6 minus 4, it is 2. So just write down all the terms there, and you will end in this one. 2 plus n minus 1, then 2. Okay, 2 is the first term for this. Then you will get what? 2n minus 2. It will be only 2n. Then it is 2n. Okay, now whenever we have a power series, okay, to analyze the convergency of this guy, we have to use ratio test. Okay, ratio test for the module of un plus 1 upon un when n goes to infinite. Okay. So what can we do here? This will be limit. Now n goes to infinite. Wherever I find n, put n plus 1. So here I've got n plus 1 upon 2n plus 1 minus 1, then time 2n plus 1, okay, divided by x to the power n upon 2n minus 1 time 2n. Okay, this is un. Okay, this is all in module. Okay, absolute value. Now what we have to do, find the limit when n goes to infinite. This will be x to the power n times x. Okay, all upon 2n. Just solve this guy. This will be this plus 1, and here 2n plus 2 okay? Time, this is flip-flop movement, you get 2n minus 1, and here 2n, then upon x power n, okay? Out with this. Then what else? This guy and this guy get out, okay? Then I will get this one in module, n goes to infinite. Here I will get, take only the greater exponent of n and this. You get here 4n squared. Also here the same, the greater guy, this and this, 4n squared. So this will be 1, and you will end only with x absolute. So we know that for x absolute for ratio test, this module of x must be less than 1 to this series to be conversion, and this module of x, absolute x, must be greater than 1 to this series to diverge. And if the module or absolute value of x is 1, so there we have test failed, okay? Test failed. So when test fails, what does it mean? It means that we have to analyze again this sequence for x equal to 1 and x equal to minus 1 here, okay? Because for x equal to 1, if this sequence, or if this series converge, then I have to put here less or equal to 1. But if for one of this value the series diverge, I have to put here less or equal to this one, okay? It's okay. Let's just solve for this one, okay? And we know this one, this is the same to write, okay, that x is lying between minus 1 and 1, okay? And for the second, this is converge. For the second one, it is the same to write x is greater than 1 and x is less than 1, okay? Just to know. And for this last one, it is the same to write x is equal to positive 1, okay, and x is equal to negative 1. So we will prove for this and this, okay? That's good. So first we have to write for x equal to 1, okay? Put here 1 to the power n upon 2n minus 1, 2n, okay? Now what's the next step? Okay, we have just to solve this one, okay? How do we solve? This one is the same, okay, as this one. This one will be 1 upon 2n minus 1 and 2n. So for this exercise, we can apply, okay? I will apply, okay, by LCD, okay? LCD, it's limit comparison test, okay? LCT, let me call LCT, limit comparison test. So what does it mean? It means that first I have to know UDN, okay, here un is equal to 1 upon, take common this one, 2n minus 1 and 2n. So this is the same as writing this one. I will take common this and this, so it will be 4n square, okay, 4n square, okay? I can just take out 4n square here, and it will be 1 minus 1 upon 2n time here, it will be only 1, okay? I just took common this 2n and this 2n here out. This is the same to write this one, just 1n square here, then put back it's 4, okay, minus 4 upon n, okay? Just like this, it is the same. I just took 2n here and 2n here. This is 4n. Then put back 4n, here 4 and here 4. If you put 4, no, it will be 2, sorry. Yes, yeah, this will be 2, okay, because here I have this one. Is that okay? 2 upon n. Nice. Now, okay, bn, okay, here, what will be bn? Bn will be 1 upon n square. 1 upon n square, it's bn. So, okay, the limit of un upon bn, when n goes to infinite, will be equal to what? This limit here must be different from 0, okay, and cannot be also infinite. So this limit will be only this part here. This limit will be 1 upon 4 minus 2 upon n. Solve this one. Actually, this will be 0, and this will be 1 by 4. 1 by 4 is a finite number. Then it's okay. So, okay, then it's okay. It's okay. 1 by 4 is different from 0. Then it is according to the condition. Now, if bn is, how can I say, is divergent, so this un will be divergent. But if bn is convergent, then bun will be convergent. How can we calculate bn convergency? See, by p series, we know that p, this one, just analyze for this one. What is p here? P is 2 greater than 1. Therefore, bn converge. Okay, by p series. Okay, p series, like whenever we have a series like this, 1 upon n to the power p. If p greater than 1, so it converge. If p less than 1, less or equal than 1, so it diverge. In this case, here p is 2. Okay, p is 2, so it converge. It means that 1 is part of the interval of convergency. Okay? Yes. Okay. Means that 1 is part of the interval of convergency. Let us now check for minus 1. For minus 1, okay, for x equal to minus 1, what we will have? We will have, okay, say the same. Then we have minus 1 to the power n upon 2n minus 1, and here 2n. In this case, we will apply, okay, because it's alternative series, so we will apply what? Leibniz. Always Leibniz. Okay, so let's first see. Okay, the module of un must be decreasing. Okay, must be a decreasing function. Let us see, must be decreasing, so it means that, let us see, module of un is what? Is only 1 upon 2n minus 1, and here 2n. So it must be decreasing. So suppose u1 will be what? Put here 1, 1, 1, 1, it will be 1 by 2. u2, it will be what? Put here 2, 2, 2, this will be 3, 3 times, put here 2, 3 times 4 will be 12. Okay, it will be 12. See? So this is decreasing. And if you put u3, you will get something like 1 upon 30. Okay, so u2 is less than u1. And, okay, u2 is less than u1. And u3 is less than u2. Okay, so it is decreasing. It is decreasing. Now it's okay. It must decrease. Then the limit of un, of module of un, okay, of the absolute value of un must be 0 to this to be convergent. Okay, now let us calculate this limit. The limit of u1 upon 2n minus 1 and 2n here, n goes to infinite. Substitute here, you get infinite. Okay, twice infinite minus 1, and here 2 times infinite. This will be 1 upon infinite, and this will be 0. Therefore, by Leibniz, okay, Leibniz test, it converge. Okay, if it converge, so now I can say that both let me write here. Okay, the interval of convergence were something like this: x less than 1 and less than minus 1, something like this one. It converge. This is the interval of convergence. Now that when x is 1 and minus 1, they also converge, I will write this one. It means that the interval of convergence is between minus 1 and 1. And the interval of divergence, it is when x is equal, when x is less than 1 and when x is greater than 1. This is divergence interval. Okay, thank you. Hope you can understand something.